Hello everyone, in this video we have a flash calculation for the system Benzene Toluene and Ethilbenzene. In this case, benzene is the compound number 1, toluene is the compound number 2, and ethilbenzene is the compound number 3. This problem is the problem number 10.9, and this is the part 8 by the book Smith by Ness, and this is for the 7th edition. Let's get started with the problem. In this part of the problem, we have this information about we have a mix of all these components. So now we need to calculate what are the composition in the phase, in the liquid, and in the global system with the temperature and the pressure. In order to do that, let's go to watch what are the equations. In this case, we can suppose that we can use the Rolle's law. So, we can write the Rolle's law for each compound that we have in the problem. We can observe that we have in here the Rolle's law for the first compound. This is the Rolle's law for the second compound and for the third compound. In this equation, the pressure is given, but we don't know any information about the saturation pressure because this depends of the temperature, and it's the same case for the other components. But in order to calculate the saturated pressure, we can use the Antoine equation. So just remember the Antoine equation, it's equals to the natural logarithm of the saturated pressure. It's equal to a constant A minus another constant B over the temperature that we have in the system plus a constant C. In this case, the number 1 makes reference that this is for the component 1. Same thing for the component 2 and the component 3. So now in this problem, we need to know what are the molar balance. In this case, we have the global molar balance like this. The feed times Ci is equal to Xi times L plus Yi times V. In this case, I makes reference the number of the component that we are talking about. F is the feed of the flash vessel. L is the total liquid flow, and V is the total vapor flow. Let's go to use this global molar balance, and we are to write it in this way. We can pass this factors multiplying to the other sign, dividing to each term, exactly like this. So we can observe that the global composition Ci is equal to Xi times the fraction of the liquid that we have in the vessel plus Yi times the fraction of the vapor that we have in the vessel flash. So let's go to write this equation but for each component exactly like this. We have that the global molar balance for the benzene is equal to this term over here. Notice that we have in here LH. LH is as reference of L over F. So it was written like this in order to transform it just in one unknown variable. Same thing for VH. VH in this case makes reference to V over F. it's written in this case in that way only to transform its just in one unknown variable. So we have the three global molar balances because we have three components in this problem. And also, we can't forget that we can write this condition over here. The sum that all the components, the fraction components in this system must be equals to 1. This is for the liquid phase and also must be true for the vapor phase. So we have exactly the same condition. In this case, we can observe that for the Rolle's law, we have three equations. In the case for the Antoine's equations, we have other three equations, and for the molar balances, we have other three equations. And these two additional conditions that must be achieve our system, so that give us a total of 11 equations. So that means that we need to have 11 unknown variables. The field information that we have in the problem is the temperature. We have temperature of 110 Celsius degree. The pressure is equals to 90 kilopascals. And this is the global compositions that we have in the feed. And also we have the Antoine's constant. This Antoine constant is for Benzene, this other for Toluene, and the last we have the constant for the Ethilbenzene. So the unknown variables are the next. We don't know which the mole fractions for the liquid phase, neither for the vapor phase. We don't have information about the pressure, the saturation pressure, and we need to know what the total liquid fraction and vapor fraction are. So those are the 11 unknown variables that we need to find. In order to do that, we can use several softwares like MATLAB, MATCAD. In this case, we are going to use Polymath in order to solve all the equations that we showed previously. Exactly like this. This is the screen of Polymath, where we had in here the three equations for the Rolle's law. Those are the three equations for the Antoine's equations. Those are the global modal balances, and those two are the two conditions that we need to achieve in order to solve this problem. In here we have the information that we know in the problem. We have the feed in the vessel flash. In here we have the constant, the Antoine's constant, the temperature, and the pressure. So now, in order to solve this system, we need to click in here, and there are all the results for this system problem. We already know what are the vapor mole fractions, the liquid mole fractions. Also, we know what are the saturation pressures are, and the total liquid fraction as the total vapor fraction. So in this way it was possible to solve these flash calculations with Polymath. It's very easy and useful use this system and this system of equations in order to solve this type of problems. So that's it for today's video. Thank you very much for watching, and see you next time. Take care.